Let's quickly talk about the mean value theorem. And the mean value theorem is really not that difficult. Some people make it sound harder than what it really is. And all it's saying is that if we have a function, f of x, and it's continuous on the interval a to b, continuous including a and b, and differentiable on a to b, this time not including a and b, then there's at least one point, that's usually called c, in a to b, where the derivative of the function at c is equal to f of b minus f of a all over b minus a. So when you kind of read it like that, it makes it sound a bit confusing because you don't really have a grasp on what it means conceptually. But let's look at this part right here. If I have this graph, f of x, and this is a and b, and I'm just going to draw a really generic graph, something like that. So what we're saying is that f of b minus f of a over b minus a, what does that mean? Well, f of b is just the value of the function f of x at b, and f of a is the value of the function of a, the value of the function at a. So f of b minus f of a is pretty much just the change in y's, and b minus a is just the change in x. So this is just the average slope. So if I kind of write down what these points were, the x-coordinate of this is b, and the y-coordinate is f of b. And once again, this point would be a comma f of a. So once again, you can see that f of b minus f of a, that's the difference in y, and b minus a is just the difference in x. And so that gives us the slope of this line right here connecting these 2 points. And all it's saying, all the mean value theorem is saying, is that if f of x is continuous on a to b and differentiable on a to b, which it is, pretty much that just means that there are no holes and no cusps, cusps being sharp points. So, this is satisfied. There's a point C where the derivative of this function is equal to the slope of this line. And, you can see that pretty easily. Some point like over here, if we took the tangent, it would look like that. And you can see that these are parallel. So the slope of this tangent, which is the derivative, is equal to this average slope. And there's also probably a point over here. So what C would be is the x value. So I'm going to call it C1 and C2. That would be the x value of the points where the slopes are equal to the average slope. So that's all that mean value theorem means. Once again, I'll just draw an even bigger graph, make it even more obvious. So just even something like that. So you can see the slope of this, and as you can see, it's differentiable and continuous. So the average slope here, and you can see that there is obviously clearly a point where the slope of the tangent line, or the derivative, is equal to this slope. So this would be A, this would be B, and this would be C. And just to solve for C, then you take the derivative at that point C, and you'd need to set that equal to this the slope of this line, which is just f of b minus f of a, the change in y, over b minus a, which is the change in x.